We are on domain and range day 2. All right, and let's get right to the learning goals. I can determine whether different relations represent a function and determine whether a graph represents a function. Fun stuff. So let's use the following figures and determine which relation is not a function, and we need to explain our reasoning. So if we look, remember, for it to be a function, it needs to have only one y. So here we have an x, only one y. Different x, only one y. Different x, only one y. Different x, only one y. Which means it is a function because all the x values are unique. If we look here, all we have to do is say, well, if we go down, there's only one -5, nothing else there. Here we have a +1, but look right underneath it, another +1. This is bad right here. All right, so that is not a function because there's a repetition of x values. And then if we look here, 2, 3, 5, 8, 12. No repetition of x values, so it is a function. Yes, there are unique x values. So that's explaining the reasoning because of this. Explaining the reasoning why it's not a function. Repetition of x values. Why is this a function? Unique x values. Notice a trend here. Let's take a look at another one. Which relation is not a function? Well, we have 1, 2, 3, 4, 5, 6. All unique x values, but if we look at 1, it only goes to 1y. Good. 2 only goes to 1y. 3, however, goes to 0, and it goes to 4. That's bad. All right? So there's a repetition of x values because we have 2 3's basically. All right, we look here, unique x values. Only one here, one there. Okay, notice, no repetition. And then over here, 4, 6, 0, 1, 5, no repetition. Unique x values. See a trend there when it's not a function? Last but not least, that should be example 1c. 1x, a y goes to c, z to b, t to d, w to e. These are all unique. Fantastic. Unique x values here. Nothing else, nothing else, nothing else. We're good. Unique x values. Oh, but look here. We have 2 1s on our table. We have a 1 with a y value of 8 and a 1 with a y value of 4. So 1 x value for 2 y values. Not good. So there's a repetition of x values. Okay. Last type of examples. Student concluded from the graph that the graph is a function. Is the student correct? Explain. Well, it is a function because if we did the vertical line test on each point, it wouldn't pass through another one. Okay, we don't have any repetition. No other x values. All the x values are unique. Student concluded that the graph represented a function. Is the student correct? In this case, so here, nothing else, nothing else, nothing else. This one though, look at that, and then look there. Okay, all those are good except for these right here. Both sets have multiple spots. So no, that is not a function because at x equals -1 and x equals 0, there are multiple values for y. So again, be aware of this explanation. Okay, when it asks you to explain, you need to make sure you're doing that. All right, and that's all I have for you today. Nice and simple, some harder problems. But again, easy to figure out. Just look for multiple x values on a graph. Just do like a vertical line test. Even though it's not a typical graph that, goes like this, that's basically the pattern it follows, and you can see, all right, so there's some spots where there could be. Now, if there's no solid graph, you've got to be aware of the points. So, because if this graph, for example, looked like this, went here, okay, even though the graph looks the same, each one of those points is on their own line. So in that case, that would be. Just be aware of that. We will get some more practice with this, especially when the videos are shorter. That means that the problems are harder. So get in your practice, come in with questions, and by all means, please take fantastic notes. Thank you guys. You have a lovely day, evening, morning, whatever it is for you.